Hello, welcome back to the lecture series on microeconomics. We have been discussing firm's long run equilibrium. Now we are going to conclude our discussion on the same, and we would like to move to the industry's long run equilibrium. So, first let us revisit the diagram that we have drawn earlier to find out what will happen if the long run market price is above the minimum long run average cost curve value. So, we have already found out the revenue and the cost associated with our initial market price P star for our representative competitive firm, right. So, in this case let us mention that the profit, that is basically revenue minus cost, takes positive, is positive in this case. So, that positive profit is given by the shaded area that is already marked with the sky blue lines, right. Now, this case where the firm earns a positive economic profit is known as the case of supernormal profit. So, what do we mean by supernormal profit? To understand supernormal profit concept, we have to introduce another new concept called normal profit. So, normal profit is basically the opportunity cost of the entrepreneur who is running the business, who is managing the firm, right. So, when a firm earns some profit which is going to take care of not only the fixed cost and the variable cost, but also this opportunity cost of the entrepreneur, then we call that as a normal profit. So, now let us look at what will happen if the firm earns a supernormal profit. A firm, if it earns supernormal profit, it is a representative firm. So, there are many other firms are making similar profit as well. So, the people who are waiting outside, they see this is a very good opportunity to enter the market, produce something and supply that to the market and earn some extra money and earn profit. So, they will start entering the market. So, if that happens, then it will have an impact on the supply in the market, right. So, in the diagram we had some initial aggregate supply curve which is sum over the individual firms supply curves, right, given by this expression here. Similarly, we had some initial level of aggregate demand curve which is given by this expression. We had already derived aggregate supply curve last time. How to derive the aggregate demand curve? This is simple. So, if you have the individual demand functions, the horizontal sum of individual demand functions give the aggregate or market demand curve. Okay. So, we have seen that at the equilibrium market price is obtained. Okay. Now, if new firms enter in the business, then what will happen? If new firms enter in the market, then basically this n, this small n, which is the number of firms here, increases, right, and that means that my market supply of output is going to increase at a given market price. So, my new aggregate supply function would be something like this broken line, right. So, let me call this S prime, right. So, at any market price, now the market supply is higher because there are more number of firms. So, now see that it will create a downward pressure on the price because new equilibrium will be obtained at the intersection of the new supply function, which is the broken purple straight line, and the red downward sloping demand function, right. So, at the new intersection, new price will be obtained and new quantity will be obtained, and as we see here, with entry of new farms, we get a new price P double star which has gone down, and we get a new output level Q double star correspondingly, and this time the market equilibrium output level has gone up, right. Okay. So, now that means that this representative firm that we started with now faces this new market price P double star, and note that as it faces the new price P double star, it will now equate the short run marginal cost and the long run marginal cost with this new price, right, and it will produce some output level. Okay. At the intersection it will reach the new equilibrium. So, the firm hits a new equilibrium at the intersection point of long run marginal cost curve and the P double star line. Note that here also the firm is earning supernormal profit, although the profit level has gone down compared to the previous level, but it is still earning a positive profit. But this is not the end of the story. Firms may enter again because there is still some positive profit to make if one particular unit of output is sold. So, some more firms will enter in the market, and that will put some pressure on the price of the factory inputs as well. So, if more land, more labor, more raw materials are required to supply, to produce and supply more number of more units of output, then basically there is a increase in demand for these factor inputs in the factor inputs market, that will rise the input prices. So, the cost, average cost, marginal cost of production will also go up. So, basically from the cost side also there will be shift in these curves. So, basically what will happen, the cost will rise and the market price is going to fall. So, in a nutshell, as a result the firm's supernormal profit is going to go down gradually, and one time will come when the price exactly becomes equal to the minimum value of the long run average cost curve. At that point there is no supernormal profit left, firm is earning zero profit, but this zero profit does not mean that there is nothing from the entrepreneur, right. There is some profit we have already saved aside for the entrepreneur as the opportunity cost embedded in the cost equation. So, this entrepreneur or owner of the business is earning some money, so that he or she will remain in the business, and then we can say that the normal profit is assured, but supernormal profit goes away. So, as supernormal profit vanishes, no more firm will enter in the market, and the market will now find a steady long run equilibrium, right. So, basically the long run equilibrium is to be obtained when price is equal to the minimum value of long run average cost. So, we can write the summary result here. So, the summary result is this. Firm's long run equilibrium condition price equals to long run marginal cost equal to the long run average cost, because note that long run marginal cost has to go through the minimum point of the long run average cost, and this is the minimum price which is required to keep our firm in the industry. If the price falls below the minimum of long run average cost, there is negative profit to make and the firm has no incentive to stay in the business. So, if firm faces a price which is lower than the minimum value of long run average cost, then the firm makes negative profit. So, if the firm makes loss, then there is no incentive for the entrepreneur or owner of the business to stay in the market, because this person is unable to secure his or her opportunity cost or normal profit. So, basically in the long run what we find? We find that firm's supernormal profit is equal to 0. So, the final equilibrium condition can be written as SMC equal to LMC equal to LAC equals to market price of commodity. So, we are done with the discussion on a firm's long run equilibrium. Now, let us look at another interesting aspect of theory of firm, which is the industry's long run equilibrium. So, one may ask, how many firms will operate in long run equilibrium in an industry, so that everybody is making some profit, but none of them are making supernormal profit. This is what we are going to discuss now. So, now we are going to make an assumption without loss of generality. So, we take the case where all firms have identical cost curves. This will simplify our discussion to a great extent. Okay. So, now let us start with a simplified diagram which portrays this basic condition for firm's long run equilibrium, that we mark by asterisks. Okay, so there will be two panels of diagrams, panel A for the individual representative firm and panel B for the market or industry. Okay. So, here we will start with the demand function first. So, let me draw the aggregate demand function AD, and there is this aggregate supply function AS, and at the intersection point market equilibrium price and equilibrium quantities are determined. Okay. Now, let us draw the cost curves, right. Okay. So, the equilibrium price is P star capital Q star Q, okay, and then we have this individual firm output denoted by small q, and all sort of cost variables and price variables are measured along the vertical axis, right. So, now we are going to take this price and superimpose in panel A diagram, right. So we have this P star. Okay, now we have to draw the cost curves, right? So basically we start with some average cost curve, okay, and there will be this marginal cost curve, okay, and we know that at the point of equilibrium, at the point of intersection of price line and the marginal cost curve, we denote the initial quantity level. For simplicity, I just assume this to be M. Okay, so let me now assume, for I intend to do some graphical analysis, so I now introduce some simplified notation. So let me assume this Q star as M. Let me introduce origin here. I can introduce origin here as well. Okay, and let me call this firm's equilibrium output level as M prime, right? Okay, so now we see that the firm is earning some supernormal profit here. So basically what will happen, the new firms will enter in the market and the price will fall. So the price will fall to an extent where in the long run equilibrium the price becomes equal to the minimum value of the long run average cost. So suppose it's here, okay. Now let me call that price as P dash. Now basically at that price there is a new supply, aggregate supply function, which is in operation because more firms has entered in the market. Let me denote this as S prime. So this is basically somewhat repetitive from my previous discussion, but I am trying to give you much simpler graphs to look at, okay. So this recap is helpful. So now what we see here, we observe that at this intersection point a new equilibrium is obtained, and corresponding to the new equilibrium market price P prime, new output level Q double star or Q prime, say Q prime, is obtained, and I denote this as N, right. So basically this is my point M, and let me make some room here, okay, and this is my point N, right. Okay, fine. So now we see that in this case firm produces right here at the minimum point of its average cost curve. So corresponding firm's equilibrium is say N prime. So the firm produces and supplies ON prime amount of output in the market. So we figured out at equilibrium N will be this number ON, which is basically the industry output divided by ON prime, which is basically the firm's output level, right. So let me write this. So this ON is basically total market supply, or you can also write this as aggregate supply, and this is basically an individual farm's supply right. So, now let me introduce this short run average cost curve and short run marginal cost curves here in this diagram for the sake of completeness. So, this is my SAC, the minimum points are basically equal, and we have to now draw the SMC, which is going to be a steeper line. It will pass through the minimum point of SAC as usual. Okay. Now, just for no confusion, I am adding this long run L in front of the previous average cost and marginal cost curves, right. Okay, so that completes our diagram. So, we have diagrammatically seen how to find the equilibrium number of farms in a competitive industry, right. Now, let us going to look at a numerical example to see if the equations are given, how to proceed to find the equilibrium value of n star. So, let us start with a cubic cost function, so that we get this U shaped marginal and average cost curves. So, I am going to give this illustration in a very general way. So, one can write some alpha times q minus beta q square plus say some gamma q cube. Okay. So, where C is the total cost and Q is the output quantity of a representative farm, right. Now, let me talk about the market demand function. Let me write that as, so Q equals A minus BP, right, where capital Q is the total demand and P is the market price. Okay, so now a question can be asked, what is the equilibrium price and the equilibrium quantity bought and sold and equilibrium number of farms in the long run of this industry, right. Okay, so we will first start with finding the long run average cost curve, and that will be basically nothing but dividing C by small q, right. So, of course, you can figure out what you are going to get, alpha minus beta q plus gamma q square. So, that will give rise to an U shaped average cost curve, right. Okay. Now, we have to minimize this long run average cost expression, right. So, that we hit the minimum point of the long run average cost curve at the bottom of the long run average cost curve, right. So, for that what to do? We need to differentiate long run average cost curve equation with respect to q, set that equal to 0, right, okay. And then we get some q star, which is basically the solution to this equation, the first order condition. And as this is the minimized value of the long run average cost, this q star gives me firm's long run equilibrium output. Okay, fine. Now we can plug this q star in LAC function, and if we do so, we get what? We get the equilibrium price. P star, right, okay. So at this price the total demand in the market is known because we already know the demand function, right. So plug P star in aggregate demand function and you will come to know the market demand at that price q star, capital Q star, right. So you know the long run industry or market clearing output level as well, right. So you do not require anything more to find out the optimal number of firms in the market. You have to just divide capital Q star by small q star. Okay, so we are done with the firms and industries long run equilibrium. Now we are going to move to the theory of market and we will start with perfect competition. So far we have talked about competitive firm, competitive industry. So now we are going to lay out a perfect competition model with the list of, with the assumptions, and we are going to discuss some more related topics which will gradually lead us to the field called welfare economics. So we are going to continue with these discussions in the next lecture.